Hey guys, what's up? Gonna pop on here for a minute, guys. It's not gonna be a long one. I just wanted to let you guys know what was going on with this. This just happened. Hey, good morning, guys. Good morning. Hey, Arizona, Becca, Darcy, Art. Good to see everybody. Mark, Tam's in the house. All right, guys. I am gonna go ahead and just get into this because I really don't have a whole lot of time, to be honest with you. I know I haven't been on here for a couple days. I've had a pretty major, it was major, loss of a friend. I'll let you guys know what's going to be going on with that and all that, as far as how much I'll be posting and all that kind of stuff. But yeah, it was very tragic. But anyway, let's just go ahead and do this real quick. Listen, guys, it was a M5 flare, and I'll tell you what, we'll just go here and show it to you on. This is spaceweather.com. Again, guys, please go over here and show them some love. These guys just do a killer job. I mean, no sooner than this thing erupted, it was posted over here, and I had already seen it. It erupted. I was looking, and then they had already had it posted up here. It just happened, like I said, back here. Now, an M5, don't nobody freak out or nothing. We do have, they did experience some radio blackouts. There's been some reporting of that. The S1, we don't talk about this S1 a whole lot, but that's when this moves. The proton flux. What that means is it's a radiation storm. Okay, and it's a small one, guys. This one, we will probably, there's not going to be much effect of any of that, right? So let me go here to the space weather scales here, and we can look. Radio blackouts, limited blackout of high frequency radio communications, loss of radio contact for tens of minutes. Understand that, guys, okay? This is an R2, so you're only talking tens of minutes of blackout radio, right? They were seeing some weird on the short band, ham radios and all that kind of thing. Emergency responders use this kind of radio most of the time, but it did not hit over here. As far as the flare itself, it was on the dark side of the planet. The day side of the planet. I'm sorry, but then we were at night, so yeah, and you know that by just looking at my thumbnail, really. I will scroll down here, and that's what you get, right? So that was the blast. That was the initial X-ray hit. Okay. Now watch what happens when we know we've had radiation afterwards, and it takes a little bit longer for the protons to get here, but they get here really fast. Even the X-ray is here in 8 minutes, so we get hit with the X-ray, and then watch what happens. Watch the pole areas up here. You're going to see all the colors start to change. There's your radiation storm right there. Okay, and a lot of times this does hang around for a minute. Okay, it hangs around, and this is pretty much the upper parts of our atmosphere. I don't think much of this, if any, is going to actually impact, make it all the way to the surface. It's not going to be a whole lot of anything, right? But I did want to show you guys this is what we look at. Now, it's an S1. Now, we've had bigger radiation things happen before, but I wanted to show you guys that progression because this one really captured it well this time. X-ray first, okay, here in 8 minutes after the flare, and then here comes the protons afterwards. It's roughly about 20 minutes, I think, for the protons to get here, at least in this excessive amount. But yeah, so yeah. Hope I didn't. Let's here for a minute. All right, and I know, guys, I haven't been posting like any kind of specific time like I used to and all that. I'm trying to get back to that. It's just been really, really difficult, especially because I thought I was there in a place, and then we've had this thing happen, and with the loss of my friend, and it's just been one thing after another. But I do look to get back to more of a steady schedule here. So, but the next question is, guys, obviously, would be, was there a CME with this? Right. Well, first, let me show you the radiation storm status here. It says biological, none. Satellite operations, none. Does not affect that, right? Other systems, minor impacts on high frequency radio in the polar regions. Okay, that's why when I show you this, that's why I was pointing out. You see this? Okay, none of that is in, down past the Arctic Circle or the Antarctic Circle. And the reason why is things come in easier on the poles. That's just how our magnetic field's set up. Hey, Bex. Sandra, Bernard, good to see everybody in here. Bruce. But yeah. And again, I kind of sprung this one on you guys anyway. Again, weird time to be posting for me, but Discover data here, guys, not much going, right? Actually, we had a G2 level storm, right? And you guys can see that right here. And that was caused from we had that weak impact back here at G1 from a glancing blow from a CME. But then we got this, and this took them by surprise. We caught that, and I think what happens is, guys, we get hit, and we're still kind of hanging high geomagnetically, and then even a slight little blow from a CME can sometimes, or a solar wind stream, can sometimes push you up like that. Notice it didn't stay there that long, and that's why. Okay, so just letting you know that. They're forecasting here right now. This may change a little bit because of current things happening. It's, we have to wait on things to get the data in. But here's your geoelectric model. Space weather's effect on our electrical grid. Again, little blips right there. That was probably when the flare hit. Again, it was on the other side of the planet, so you're not going to see much here. I mean, you can almost kind of see the angle there. Right? And if you follow that on down, where would that lead you? It would lead you to right there. You see? So just kind of, now that doesn't always happen that way. Our magnetic field absorbs a lot of it. And so that's just what's going on there. Okay. So we go over here. I am going to refresh this one. Let that one load back up. I'm going to stop these. Sorry, guys. I just threw this one together. I mean, I'm talking like quick, like. Did not have a whole lot of time here. Okay. So here's Soho. We'll take a look at it. And this thing did fire a CME. Okay. Now, whether or not the CME is directed at us because it came from a sunspot that was over here. But it doesn't mean it ain't going to hit us because we don't know yet. My guess is, looking at what I was looking at, and I'll show you seeds real quick. Right here, it does look to be going kind of where the other one was going. It's most definitely a sizable CME. It's not gigantic by no means. But again, the size of something doesn't necessarily mean the power of it. Now, again, this is looking from Earth's perspective. This is on the Soho Observatory. Sits out in front of the Earth, always looking at the sun. So as we're looking at this, things that come around the edge is what we look for, because that means it's coming at us. Notice how you're seeing a lot of this energy go off that way and to the north. So if we take that in consideration, we go back over here to ISWA real quick, see if this thing's loaded up yet. No, it's taken 5 years to do so. I'm shutting those off right there because that's just eating up the memory there. But anyway, so again, that we are talking about on the 22nd, a different CME may impact us. It's going to be a glancing blow. It does look like that's going to happen. Now, what happens with that, I still look for weak like stuff. These are not direct hits. So understand that. Now, while that's loading over there, we can talk about the polar stratospheric clouds. These are pretty cool, guys. You guys should read up on these.
They're over the poles, you know, in the southern and northern parts of our planet. These are not aurora. All right, this is sunlight and moonlight reflecting off ice crystals in the atmosphere, and you know, noctilucent clouds are not the same either. Noctilucent clouds are these, and that's when just around our polar areas, water vapor gets up there and um, freezes around meteor dust. So that's what causes those. But that's moonlight for the stratospheric clouds, and that's daytime. So, and this was a pretty decent outburst. I won't call them outbursts, but event here. This is a larger, more sustained event is probably the best word for it. But there's that flare. Let's see if this stupid thing's loaded yet. Almost. Dumb thing. I swear. Sometimes, yeah, if I stay here on this page, it'll probably load faster. But yeah. Okay. Spartan Negative, what's up? That's cool, Spartan. I like that. I like that kind of stuff. Really cool stuff. All right. So you see what you seen right there? That was probably, I don't know that, no, because the time wasn't lining up there. Okay. So it wasn't it, but we've had some other things popping off, and there's that CME, or not CME, but the flare. Yeah. And it's not easy to see. You know, it's right here. You see that? I guess that is easy to see, but I guess I could zoom in, might make it a little bit better, huh? So if we're looking at that, obviously, you know, we talk about the X pattern it takes. That does not mean it's an X flare. All it means is that's how the camera interprets that light. Okay. Again, look where it's located. So if you can picture the Earth, you know, looking directly at the sun, most of the stuff that's coming off this thing, if it is, you know, it did have a CME, it looked to be, is going to fire that way, right? Now, it doesn't mean it can't wrap around, because we've seen that before, but I don't think this would be a direct, like, smack in our face. Now, it can. Depends on what angle that fired off at, right? Whatever angle that left the sun, that's what we got to look at, and we don't know any of that data yet. So, that's where we're at on that part of it anyway. Let me show you the 94 angstrom. This one usually shows the flare stuff pretty well. Yeah, that's not working. Let's do it this way. Okay. Yeah. Now I want to show you guys something here, because I noticed this earlier. All right. Now this wasn't just a little quick burst. This actually was kind of a longer duration one. You see how it starts popping right there? And see how it hang around? Now, I want you guys to notice something here. This pops off. Now watch it disrupt this one. See that? So that stuff was reacting to it. So, you know, some of that energy did disrupt that part of the sun. So, you know, it's possible some of the scene, you know, if we get a bunch of plasma leaving the sun off of this, you know, that is what it is. But that's pretty much it, guys. I wanted to come on and just give you a little update on that. Yeah, so I think I'm going to go ahead and end it there, guys. Thanks for stopping in. I'll try to give you guys updates if I can, if I have the time and everything with everything going on. But, yeah. And also, guys, please go over and check out, we did a live stream with Rip over on the Lifeboat. The links are in my description. Please go over and check them out. Rip did a really good job. Rip Curl. You guys know Rip. I know you guys do. And then we did another interview last night with one of the crew member over on the Lifeboat. His name is Niall, and he was fighting alcoholism, and he shared his story. So I would really, you know, appreciate you guys if you guys would go over and give them some view, go over and check it out, and get some views on that.
And, you know, because it can help. Even if you don't have those kinds of issues, I'm sure you probably know somebody that does. And hearing somebody's real story really does affect you in a different way. And it was completely raw. There was no script or anything. Niall just told his story. Same thing with Rip. So please go over to the lifeboat and check that out, guys. But I am going to go ahead and get off here, guys. So have a good day. God bless. Yahusha saves, and